Ever wondered who was David Hilbert and why he ranks among the most influential mathematicians of the 19th and early 20th centuries? Born on a chilly winter day in January 1862, in the town of Wehlau near Königsberg, Prussia, David Hilbert was destined for greatness. His father, Otto Hilbert, a judicial counselor and judge, and his mother, Maria Therese Erdmann, a woman fascinated by philosophy and prime numbers, provided an intellectual environment that nurtured the young Hilbert's curious mind. Raised under a strict discipline, this environment shaped Hilbert's mind, preparing it to delve into the intricate world of mathematical abstractions and theories. His childhood was a testament to the saying, "As the twig is bent, so grows the tree." The disciplined upbringing laid the foundation for a journey that would eventually lead him to reshape the world of mathematics. Thus began the journey of a man who would reshape the world of mathematics. Hilbert's intellectual voyage started in Pisa, but his mathematical prowess truly began to shine in Florence. The young Hilbert, nurtured in the intellectually stimulating environment of the Royal Friedrichskolleg and later the Wilhelm Gymnasium, displayed an early inclination towards complex mathematical problems. But it was at the University of Königsberg where his mathematical journey truly took flight. Initially drawn to medicine, Hilbert soon realized that his heart lay not in the mysteries of the human body, but in the abstract wonders of numbers, equations, and theories. Abandoning his medical studies, he dove headfirst into the world of mathematics. His doctoral thesis on invariant properties of algebraic forms was a testament to his originality and his ability to delve into the complexities of mathematical abstractions. This work won him admiration from contemporaries and mentors alike, laying a solid foundation for his future contributions to the field. With a doctoral thesis showcasing his originality, Hilbert was ready to make his mark. From a private docent to a full professorship, Hilbert's career was on a meteoric rise. Picture this: a young, ambitious mathematician, fresh from his doctoral studies, stepping into the world of academia as a private docent at the University of Königsberg. This was Hilbert's first taste of professional life, a stepping stone to the prestigious professorship that awaited him. And while his career was taking flight, so was his personal life. In 1892, Hilbert found love and stability in his marriage to Käthe Jarosch, his second cousin. Their union provided a harmonious backdrop to his professional pursuits, the perfect equilibrium to his demanding academic journey. But the real turning point in Hilbert's career came with his move to the University of Göttingen in 1895. This wasn't just a geographical relocation, it was a shift in his professional landscape. Göttingen was a hallowed ground for mathematics, a place where great minds gathered to challenge, innovate, and redefine the boundaries of the discipline. Here, Hilbert's influence began to permeate beyond the confines of his classroom. His work in geometry, especially his publication of Grundlagen der Geometrie in 1899, sent ripples through the mathematical community, redefining the discipline after Euclid. His axiomatic approach laid the groundwork for 20th century mathematics, emphasizing the importance of rigorous proofs and the need to question the obvious. And it was at Göttingen that Hilbert's influence truly began to expand. In Göttingen, Hilbert redefined geometry and laid the groundwork for 20th century mathematics. His magnum opus, Grundlagen der Geometrie, published in 1899, was a watershed moment for the discipline. Hilbert's axiomatic approach to geometry was transformative, challenging the foundations laid by Euclid more than 2 millennia prior. In this seminal work, Hilbert proposed a set of 20 axioms, a concise and logically coherent framework that laid bare the essence of geometry. This revolutionary approach emphasized the importance of rigorous proofs and the need to question the obvious. It was a clear departure from the traditional reliance on intuitive understanding, marking a pivotal shift towards abstraction in mathematics. But Hilbert's mathematical prowess was not limited to geometry alone. He made significant strides in algebraic number theory, a feat encapsulated in his Zahlbericht of 1897. This monumental work synthesized and extended the findings of his predecessors, including Kummer, Kronecker, and Dedekind. In doing so, Hilbert laid the foundations for class field theory, a branch of algebraic number theory that continues to be a subject of intense research to this day. Hilbert's versatility in mathematics was evident in his work on invariants, functional analysis, and mathematical physics. His pioneering research in invariants, mathematical entities that remain unchanged under transformations, was groundbreaking. It set the stage for the development of invariant theory, a critical tool in modern algebra and number theory. His work in functional analysis, a branch of mathematics concerned with infinite-dimensional vector spaces, was equally significant. Hilbert's introduction of the concept of a Hilbert space, a complete inner product space, revolutionized the field. This concept has since become a cornerstone of functional analysis and quantum mechanics. Hilbert's contributions to mathematical physics were also noteworthy. His work on integral equations, a type of equation in which an unknown function appears under an integral sign, was pioneering. It led to the development of methods for solving these equations, which are now integral to mathematical physics. David Hilbert's mathematical innovations were nothing short of transformational. His axiomatic approach to geometry, his work in algebraic number theory, his pioneering research in invariants, functional analysis, and mathematical physics, all these contributions reshaped the landscape of mathematics in the 20th century. But perhaps his most famous contribution was yet to come. At the turn of the century, Hilbert presented the world with 23 open problems. This wasn't just a random assortment of mathematical conundrums. These were the questions that Hilbert believed would define the direction of mathematical research in the century to come. Each of these problems was a mountain peak in the mathematical landscape. They represented the most profound and complex challenges of the time, and Hilbert was inviting the world to climb these peaks, to conquer these challenges. His optimism about the potential of mathematics was evident in this audacious challenge. He believed in the power of the human mind, in its ability to unravel the deepest secrets of the universe through the language of mathematics. These problems covered a wide range of mathematical areas, from number theory and algebra to geometry and analysis. They were a testament to Hilbert's versatility and his ability to see connections across different domains of mathematics. When he presented these problems at the Paris Conference in 1900, Hilbert was setting the stage for a new era of mathematical research. His problems sparked a flurry of activity. They inspired generations of mathematicians to push the boundaries of knowledge and to seek answers to questions that had been considered unanswerable. These problems continue to challenge mathematicians to this day. They represent the eternal quest for knowledge, the never-ending journey to understand the universe in the language of mathematics. Hilbert's name lives on in the concept of Hilbert space, a cornerstone of functional analysis and quantum mechanics. This space, in essence, is an abstract vector space that provides the setting for the mathematical formulation of quantum mechanics. Hilbert's work on integral equations played a pivotal role in the development of this concept, which has had profound implications for our understanding of the universe. His inquiries didn't stop there, though. Hilbert also ventured into mathematical physics, where he contributed significantly to the field. His work provided the foundation for many of the modern theories and models we use today. Furthermore, Hilbert made attempts at establishing a proof theory, a branch of mathematical logic that represents proofs as formal mathematical objects. This endeavor, although thwarted by Gödel's incompleteness theorems, nonetheless pushed the boundaries of mathematical logic and the philosophy of mathematics. However, Hilbert's final years were overshadowed by the political upheavals of the 1930s. The rise of the Nazi regime and the subsequent dismissal of Jewish scholars deeply affected him, casting a somber shadow over his illustrious tenure at Göttingen. Yet, in spite of these challenges, Hilbert's legacy endured. His contributions to mathematics continue to inspire and guide scholars and enthusiasts alike. His name, forever etched in the annals of mathematical history, serves as a beacon of intellectual curiosity, rigor, and brilliance. Despite these challenges, Hilbert's legacy endured, forever marking him as one of the greats of mathematics.